this is the most general expression for x. So cosine of omega t minus a phase shift has to be equal to, in this case, it's equal to minus sine. I could rewrite this as minus a sine of omega t. Okay, the only way to get a sine from a cosine via a phase shift is if that phase shift is pi over 2 or 3 pi over 2. Okay? So, then it follows that the tangent of delta must be infinity. And there we go. Other questions? All right, let's switch gears. We have some velocity dependent force F, given magnitude of F is a constant times the magnitude of V raised to the power n. N is at this point unknown, and the direction of F is opposite the direction of V. And suppose I give you V is equal to the initial value over 1 plus gamma t, where gamma is, for the moment, just some unknown constant. Figure out whether x of t is bounded or not, meaning that is this object going to eventually come to a stop at some finite distance from the starting point, or will the distance from the starting point grow without bound? And keep in mind, this is a function that decays to 0 as t goes to infinity. So you tell me whether, based on all of the information available, it comes to a stop as t goes to infinity. By the way, everything that I'm discussing here is not the entirety of what will be on the test. Anything from the midterms is fair game. This is just some of it. Anything from the last 2 homeworks is fair game. Yeah.
V naught is given?
What?
V naught is given?
Yeah. V naught is finite. Does it come to a stop or not? Give you a few more minutes and then we'll take a vote on it. Yeah, definitely throwing the power on. That also gives me some more information here. I've also given V is V naught over 1 plus gamma t. let's take a vote. How many say that x of t will remain, that x of t is bounded, that there's a finite distance it will travel? How many say that the distance traveled will diverge with time? A few more. Well, let's see here. Given v, if we think way back to prior to the cooling of the Earth's crust, in Physics 131, what's the relationship between velocity and position? Okay, so x should be the integral of vx dt. So x should be the integral from 0 to t of vx naught over 1 plus gamma t prime dt prime, which is vx naught, vx of 0 over gamma times ln of 1 plus gamma t prime from 0 to 0 to t, right? Because the derivative of this thing, when we take the derivative of this thing, we're going to get the derivative logarithm is always 1 over the thing you take the log of. By the chain rule, we're going to get a factor of gamma, which cancels out the gamma there, which is v naught over gamma vx naught over gamma times ln of 1 plus gamma t minus ln of 1. ln of 1, last I checked, is 0. And what happens to ln of 1 plus gamma t as t goes to infinity? Blows up. This should be easy. I gave you v of t. I asked you if x is bounded.
And v of t isn't a mess.
What?
V of t isn't a mess.
Yeah.
Yeah, it's not a huge mess. It's a pretty easily integrable thing. If I told you that v of t is some really, really ungodly function, then yeah, maybe you could be forgiven. But even then, you should be able to figure out if the integral diverges or not. One thing that many people wrote on the midterm was just, oh, well, v goes to 0 as t goes to infinity. Therefore, if our integrand goes to 0, the integral is finite. Not always.
I don't understand why. Like, it makes sense, the math makes sense, but I don't exactly connect the physics of why, if the velocity is bounded through time, like if it converges to 0.
No, if the integrand converges to 0, the integral may or may not blow up. The fact that the integrand goes to 0, the fact that the velocity goes to 0 is not sufficient to work out whether or not the integral blows up.
Yeah.
You're not sure why?
I'm not sure about the physics of it. I know, like, the area will be greater than 0 sometimes.
Basically because it's slowing down too slowly, all right? You know, if the integral goes to 0 really slowly, then the area diverges and the object slows down, but it takes a long time to slow down. Whereas if the integrand goes to 0 rapidly, then it slows down really quickly and stops very soon. A lot of people just said, oh, integrand goes to 0, velocity goes to 0, it converges. Well, not necessarily. This one, the integrand goes to 0 and it diverges. I could give you plenty of integrands that go to 0 and it diverges. I could give you plenty where it goes to 0 and it converges. Here's another question. What's n? This, you think n is 1? Well, let's see here. So what's your MA is mdv, max is mdvx dt. Let's see here. So the derivative of velocity with respect to time is, well, you tell me, what's the derivative of this expression?
squared.
Yeah, 1 plus gamma t squared. So it's going to be minus gamma v naught over 1 plus gamma t squared. This looks like the square, it looks like it's proportional to the square of velocity. There's going to be some factors to work out, but it's definitely proportional to the square of velocity. So you tell me if it's proportional to the square of velocity. I really hope you don't say n is 1. I heard some people saying n is 1 before, but for Christ's sake, don't just guess. Figure it out using basic definitions. That's all that physics training is. It's 4 years of figuring